So our quadratic word problems. Now, when we're dealing with our quadratic word problems, there's really kind of three questions they basically ask us. So you're going to have a quadratic. 99% of the time, it's going to be an upside down quadratic like that. That's generally the way they work out for our word problems. So questions that they would ask you are questions that would require you to find a root or a zero. So those would be questions like, when does the ball reach the ground again? Or when does it have a height of 0? Or when do you have 0 profit? So those kinds of questions are asking you to find your root or your 0. So that would be our factoring or our quadratic formula, something along those lines to get that kind of answer. The other questions they ask involve your vertex. So those kinds of questions would ask you, for example, when does it reach its maximum height? In which case, you are looking for the x value of when it reaches that height. That x value is our axis of symmetry. So that's what we would be looking for that one. And then a lot of times after they ask you when does it reach that height, it'll ask you what is that maximum height. So then you would just simply plug that number in and get your height value. So again, we're always asking generally when does it reach the maximum or when is it going to reach the ground. So you got to know when you're going to use which of the two formulas. So if they ask you when is it looking for its maximum height, we have to use this formula. X equals negative b over 2a. You guys remember negative b over 2a? Does it sound familiar, hopefully? If you have a hard time remembering your negative b over 2a, since they give you your quadratic formula, you can always look at your quadratic formula and it's a part of your quadratic formula. It's the stuff not in the radical. That is the x value from your vertex, negative b over 2a. So then again, once you get it, the way they usually write your vertex is it's negative b over 2a, comma y. So you find that x value using that formula, and then you plug it in to get your y value. So let's take a look at our first example here. We have an object is fired upwards with an initial velocity of 112 feet per second. Its height in feet above the ground as a function of time in seconds since it was fired is given by the equation here. Find the time that the rocket reaches its greatest height. So again, we're looking for the time, so we're looking for a value of t when it reaches its maximum height. So that means we're looking for the vertex, because that's when it's going to be up at its maximum. So instead of x, though, I'm going to use a t equals negative b over 2a, simply because that's the letter they're using, so I got to keep it consistent. What would be our b value from our equation they gave us? 112, so we're going to have a negative 112 there. Our a value is a negative 16, so I have 2 times negative 16 on the bottom. So I have a negative 112 divided by a negative 32. Let's have you guys divide that out for me. Please and thank you. .5. So 3.5 seconds. That's how long it will take for it to reach its maximum height. So then the next part says, algebraically determine when the ground will reach, or when the rocket will reach the ground. So when it reaches the ground, that means it has a height of 0. So you have to keep that in mind. When you've gone back down to the ground, we have a height of 0. So we're going to plug 0 in for the h part of your equation up there. So we're going to have 0 equals negative 16t squared plus 112t. So now let's do a GCF factor over here. What goes into both a negative 16t squared and 112t? Well, let's see. What's 112 divided by 16? Does that work? 7? So yeah, so we can pull out a negative 16t. So that means I'd be left with t minus 7. So just like we've been doing for our other quadratics, we're going to set these both equal to 0. So one of my answers is a 7. What would the other answer be? 0, because you would have negative 16t equals 0. You would divide by the negative 16. So t equals 0. So we're looking for when the rocket reaches the ground. So am I going to keep time of 0? No, because that's the beginning. It's not when the rocket reaches the ground. That's when the whole problem starts. So the rocket reaches the ground after 7 seconds. It is, but it doesn't always work out that way. So you can't just always double it because a lot of times it doesn't work out. Alright, let's try our next one. The height of a ball above the ground at time t seconds is given by here. So here's our equation. When does the particle attain its greatest height? Well, that's a typo. When does the ball attain its greatest height, and then what is that height? So again, if we're looking for when it gets its greatest height, we're looking for its vertex. So I'm going to use t equals negative b over 2a. I'm not using the x simply because I have t in my formula and not an x in my formula. So what is our b value we're going to plug in? 140. Our a value is a what? Negative 2. So I have 2 times negative 2. So that gives us 140 over negative 4. Oh, I forgot my negative sign here. So it's going to end up being a positive time. What was it? 35 seconds. So that ball is going to be in the air for a very long time if it's only at its maximum height after 35 seconds. So then they want to know what is that height. So all we're going to do is we're going to take our 35 that we got and we're going to plug it in for the t of the equation. So that's negative 2 times 35 squared plus 140 times 35 plus 1600. So go ahead, type that in your calculator. Let's see what we get for our height. $4,150? 4,050, okay. So our height would be 4,050. Now they didn't give us the units for our height, so I'm just going to leave that as 4,050. Probably. But if you think about it, this ball started 1,600 feet above the ground. So it started pretty high up already. Could be in inches. Because they didn't give us our unit. Okay. Alright, next one. We have a cliff diver in Acapulco jumps from a cliff 17 meters above the water. His height in meters from the water t seconds after he jumps is given by the formula here. How long will it take for the diver to reach her maximum height? Well, look at that. Switch from a he to a she. Alright. So, we got our equation. We're looking for how long it takes for them to reach their maximum height. So, what formula are we going to use? Negative b over 2a. Nope, because they start 17 meters up and then they jump up and then down. You can't really jump down off the cliff. You got to go up a little bit first. But you still go up a little bit. Alright, so our b value is negative 1.5. Our a value is negative 4.9, so 2 times negative 4.9. So we get t equals negative 1.5. 2 times negative 4.9 gives us negative 9.8, I think. So what do we get? It's going to be a decimal. Yes, please. So does it take him very long to reach his maximum height? No, not even a full second. So that tells me his maximum height isn't much higher than the 17 meters. Alright, let's go to the golf ball. We have the path of a golf ball for a new player is given by the equation here, where x represents the distance in yards from the player, and f of x represents the height in feet that a ball goes up. Find the total number of yards that the ball travels. So you're looking for its horizontal distance. So we're looking for a height of what if we're looking for it to hit the ground? Height of 0. Our height, though, is f of x this time, is what they told us. So we're going to put 0 in for f of x. So we're going to have 0 equals a negative 0.015 times x minus 23.7 squared plus 9.1. That's a 0. Okay, so because this is written like this, x minus 23.7 squared, I'm going to get that on its own and then take the square root of both sides to get my answer. So I'm going to subtract my 9.1. So I have negative 9.1 equals negative 0.015. X minus 23.7 squared. So now how do we get rid of that negative 0.015? Divide. .6 repeating. Okay. So now, as I said, my whole plan was to do this so I could take the square root of both sides. So now what's our square root of 606.6 repeating? It's going to be a plus or minus out in front. We'll go with a decimal to the nearest tenth. So 24.6 is going to equal our x minus our 23.7. So what do we want to do with our 23.7? Add it. So now to get our x value, we actually have to do both of them. So we have to do 23.7 plus the 24.6. And the 23.7 minus the 24.6. We have to actually get both answers. So when we add the two of them, what do we get? I think it's 48.3. It doesn't matter, you're still going to get a negative number. We'll still get negative 0.9. Which that's 48.3. I don't know why that connected there. So are we going to keep both of those? No. I mean, we're going to assume he's a decent golfer and then his ball didn't go backwards. So we wouldn't want the negative. Yeah, he's new, but we're still going to give him the benefit of the doubt that it didn't go backwards. So did they give us, yeah, here, yards. So it was 48.3 yards. That's how far his ball went. Okay, next one. We got the height and feet of a bottle rocket is given by this equation here, where t is the time in seconds. How long will it take for the rocket to return to the ground? So again, if it's coming back to the ground, we're looking for a height of what? 0. So we're going to set our equation equal to 0. So again, we're going to have a Gcf factor here. What will our Gcf factor be? 16t. So we would have 10 minus t when we take out our 16t. So in setting those equal to 0, one of our answers is t equals 10. Our other answer is t equals what? 0. So they're looking for when it returns to the ground. So it's not going to be our 0, because that's when it leaves the ground. We're looking for it to return to the ground. So it's going to take 10 seconds. So then the next part wants to know, what is the height after 2 seconds? So what do you think we're going to do with the 2? Plug it in. So h of 2 equals 160 times 2 minus 16 times 2 squared. So let's see here. 160 times 2 is 320. 2 squared is 4 times 16 would be 64. So 256. What is it? Do they tell us feet, yards, what? Feet. So it's 256 feet. So now they want to know, for how long will the rocket be at or above 100 feet? So what we're going to do is we're going to take our equation and set it equal to 100. Because they're looking for when it's at or above 100 feet. So we're going to figure out the 2 times when it hits 100 feet. So I'm not going to bring my 100 over. I'm going to add my 16t squared over. So then I have a positive t squared. It's easier to factor. And subtract my 160t. So I now have 16t squared minus 160t plus 100 equals 0. So let's see here. We got to figure out if this is going to be factorable or not. Oh, they all can be divided by 4? All right. So we'll divide everything by 4 to try to make it a little easier to factor. Minus 40t plus 25. There we go. 4t squared minus 40t plus 25. So let's see here. I know my signs are both going to be negative because this right here means my signs are the same. The subtraction in front of the 40 tells me they're both going to be negative. To get 25, we could use 5 and 5. But then for the 4, we could use 4 and 1. But that doesn't give us enough. That would give us 25. Let's see here. If I use 25 and 1, that's too much. So this isn't factorable. So what do we want to do? Do we want to try to do completing the square, or do we want to use our quadratic equation? Okay. So in order to do completing the square, we would have to divide everything by 4 again, because you need to make sure that t squared there is just a 1t squared. You can't have your 4t squared. So that would give me t squared minus 10t plus 25 over 4 equals 0. Or we could put the decimal in there instead of 25 over 4. What's our decimal for that? So we'll change that to 6.25. So I'm going to subtract my 6.25 over and put my space in there for completing the square. So half of 10 and then squared gives us what? 25. So I have t minus 5 squared when I factor that left side equals, if my memory is correct, it would be 18.75. So now we'll take the square root of both sides. So let's get the decimal for 18, the square root of 18.75. Is that what we get? 4.3? Okay, so we'll go with just that one. So now we'll add our 5 over. So we have t equals 5 plus the 4.3. T equals 5 minus the 4.3. So when I add them, (9.3), subtract them, we get 0.7. So again, looking back at the question, they wanted to know for how long will the rocket be at or above 100 feet. So if you're kind of thinking of the picture here, here's our parabola, here's our 100 feet, so 0.7 to 9.3 seconds is when it's at or above 100 feet. So we need to subtract these two numbers. So 9.3 minus our 0.7 gives us 8.6 seconds. So for 8.6 seconds, it is at or above 100 feet. So one of them would be to find your X-intercepts, which really your X-intercepts are your roots and your zeros. All three of those words mean the same exact thing. They just like to interchange those different words. So if we're looking for our X-intercepts, you're going to plug a 0 in for Y because your X-intercepts are on the X-axis. So your Y value is a 0 at that point in time. So that's why we plug 0 in for Y. So on this one, we can factor. What multiplies to give us 2? 1 and 2. Which one's going to be my negative? The 2. So I got x plus 1, x minus 2. So I get 2 and negative 1 when I set them equal to 0. So those are our X-intercepts, 2 and negative 1 for that graph. For your Y-intercepts, you're going to plug a 0 in for X, because your Y-intercept on your Y-axis would be when your X is a 0. So for this one, you would have 0 squared minus 0 minus 2. What happens with my 0 squared and my minus 0? They're just gone. So our Y-intercept would be Y equals negative 2. And then our last part, our domain and range. We're going to talk more about domain and range in our next unit with our functions. But with a leading positive coefficient, your domain is always going to be all the real numbers, especially if there's arrows on the ends. That tells you your graph keeps going on forever. It's going to hit every single x value that exists. So your domain is all the real numbers. If you remember back in 9th grade, we used those 3 letters to represent all the real numbers. X, E, R. X is an element of the reals. So our range for this, range are your Y's. If you look at it, this is the lowest point, and then all of your range values are everything higher than that. What is that number right there? 3. So since it's everything higher, Y is greater than or equal to 3. Over here for the other one, though, we got a graph that's pointing downwards. So again, your domain is still all the real numbers. It's going to be every single x value that exists. However, our range this time is everything lower than that number. So Y is less than or equal to negative 3 because it's going down. All right.